Okay, so we're gonna talk about partial derivatives because I have revamped it. First of all, I deleted the first question because I realized the first question was not good. It had partial t, and I realized partial t, huh? Well, that's kind of like a general thing that we do in 1D anyway, so it kind of makes sense it'll work, and they probably think of it as a random constant that v is and a is. So I changed that and did f of y, partial derivative of y, where x is a function of t and y is a function of t, even though x and y can be a function of anything, it could be a function of pressure, temperature, whatever. But um, that's what I started off with. And I did the derivative of that, but I wanted to show visualization of it. And I did the visualization here. Clearly, I didn't do the same question for the visualization, which now I realize maybe I should have done. But this is the fun thing I've been doing for the last past I don't know how long, and I've been procrastinating on doing my Jacobian shenanigans that I should probably do now. Um, I don't want to do my Jacobian section because Jacobian uh, wants me to barf myself out because it's very impressive what Jacobian did, but it's very annoying to do that entire proof of that. Not proof, but entire like why. I mean, it's not, I don't need to explain why. I just have to show it off. But it's basically doing a huge S determinant that gets rid of this problem where I did over here. Well, let's just show you what the big problem is. I think it's over here. It will show up here. This big shenanigans will turn to a very simple rectangular um, thing with u substitution. It's basically u sub for 3D and 2D shenanigans. Um, that's why Jacobian is needed. When we deal with 1D, we don't need that because it turns to 1, I believe, or something like that. But when you go to 2D, 3D, when you change coordinates, you need to deal with Jacobian, which is sometimes a pain in the ass to deal with. Um, it can become pain because what you do is take a big mate. You have to do u dx or xx and then u xy u vx y I believe and v yy I think something like that, and then take a determinant of that. It makes things easier, I believe. Actually, in my opinion, it does, but it's hard to explain why it works. It's because I think in 20E, I just believed it works because it worked out easier. Um, Fun fact, I think this big ass equation I made was because I didn't believe in the Jacobian, and it turns out the Jacobian gives you the same number. So now I believe it after doing this big shenanigans. I partly put this in here because this is suffering, and this suffering is only suffering because I'm stupid. Um, Literally, because that question is easy as f if you choose Jacobian method. Anyway, I've been procrastinating, but I think I revamped. Yeah, I did revamp the partial derivatives today, so we're going to talk about that update. So you see how there's an x over here. That is the same thing as the purple, same thing as this one. But as you can see, partial derivative is a derivative in one direction. So in this case, the x z y or the z x direction plane will be the slope in that area. So you kind of see how it works, and you have to use parameterization to figure out the tangent line over there, which is another reason why you should learn parameterization because it gives you some leeway on why it works. I don't know. I'm just justifying learning parameterization. Anyway, there's the harmonic, which I didn't touch, but the most interesting one is I actually finally proved this thing over here, which I think last time I just left it empty and just said that works. I'm not proving it, but this time I proved it. It works. And then because of that, I could prove the differentiality of this thing, which I didn't realize how hard that would be when I did this limit over here. The limit over here only works because I did a Taylor series expansion. And if you don't know, error is error that shows how fast it goes to zero. So um, I was able to prove it with two Taylor series, and this Taylor series works because it's an exact function and polynomial function. So the order is just that. I put r here. It's actually x plus y, but I was to what's the right word? To lacking space. And I believe some people would write x squared plus y squared, but I chose x minus 1 to show that if you plug this in, it will just keep on going to 0, and it just shows how fast 0 will go to. So, yeah, that's pretty much why I put that there. Um, and it makes more intuitive sense to most people, I think. Anyway, that's how I proved this limit. This limit is a pain in the ass, and you kind of have to understand that this will cancel out with this. And it does cancel out, which is shocking enough. I didn't expect this tangent to do that. I got incredibly lucky, or maybe me choosing 0, 1 helped me somehow. I just think I got lucky. Probably if you chose another point, you'd probably need a bigger polynomial, I'm guessing. Um, my guess. It might be wrong. I don't know. I might be completely talking horseshit right now. Anyway, that's what I figured out. That's all I changed, I believe, unless I changed something at the bottom over here, which I didn't, because I was copying and pasting a little bit over here when I wrote something over here. And realized I should probably move that over here, which is the differentiate part, and then that's why it's up over here. This part, and I realized I probably should do one problem, which is why I chose this problem to do, which I made up earlier. I didn't realize it would be a pain in the ass and make me do Taylor series again, which good God, I need to stop doing Taylor series. This is like the third time I'm complaining about it. This time I didn't show all the steps because it's a pain in the ass and I never want to touch it ever again. Um, oh shit, is Taylor series at where when? Oh no, I did Taylor series over here. I did something that I shouldn't have done. I did something I shouldn't have done. I talk all partial. Oh, this is a little bit of a problem. Is it? Oh, it kind of is. But I need partial to teach the Taylor series. No. Okay, this is a little bit of a letdown. Mm, mm, mm. Should I copy this thing and put it down there? No, no, no. I like this too much to put it down there. Um, wow, I didn't expect this problem. I did not realize I put Taylor series after this, so I shouldn't be doing 2D Taylor series over here. Oh, this will make people run away from my book if you ever see this. Um, huh. You know what? I'm gonna say. Ah, shit, I messed up. Where did I messed up that badly? The thing is, I want to put this here because. Oh, oh no. How am I gonna explain this then? Is there a different way to explain this type of you know what? In doubt, write given. um, so if I write given, everything goes away because I gave you the given. I gave you it, so it should be fine. I gave you this too. Um, first order. Um, first order. You know what? Given, and then we could just put it that way. Given. I'll just say I gave you it. uh, because that's the only way I can justify this question. Until later on, I didn't expect you need to have Taylor series. For, I thought I put Taylor. I made this book and I put Taylor series later, but I thought Taylor series earlier. But I'm being a dumbass here. So, uh oh.